Hi there. Today we're going to talk about section 3.4 in your algebra book, which is on direct variation. Direct variation is closely related to linear equations. In fact, direct variation equations are a kind of linear equation. They're a specific kind. Now, first of all, let's use an example to explain what direct variation is. Suppose you have some chickens. Well, actually, let's suppose you have no chickens. How many eggs are you going to get from your chickens if you have no chickens? I would say you're going to get no eggs. So let's do this way. Let's put chickens along this axis and eggs along this axis. All right. If you have no chickens, you have no eggs. You go out and buy a chicken and just pretend for a moment that your chicken is going to lay 2 eggs per day. Now that would be interesting because most chickens that I know of lay 1 egg per day. But we're going to pretend. So if you get 1 chicken, I go out 1 along the chicken line here, and I go up 2 along in the egg direction. 1 chicken, 2 eggs. All right, you decide that you want more eggs. So you get another chicken. Now you have 2 chickens and you're going to get 4 eggs. 3 chickens, 6 eggs. 4 chickens, 8 eggs. 5 chickens, 10 eggs. All right? The idea here is you have a direct variation situation in which the number of eggs varies directly with the number of chickens. Now, there's a small problem here that you may have noticed, and that is if I draw a line here, the assumption then is that I have what's called a continuous function. That is to say, anywhere along this line will tell me the number of chickens and the number of eggs. So, for example, if I were to look along here and say at 1.5 chickens, that's going to give me 4 eggs. No, not quite. If I go out here to 1.5, no, that's going to give me 3 eggs. Now the problem, of course, is 1.5 chickens do not lay 3 eggs. I don't think a half a chicken lays 1 egg. But we're going to use it because I think it demonstrates the concept of direct variation. Notice that the Y-intercept in direct variation is at 0. And in this case, there's nothing in the negative column. You can't really get negative chickens and thereby get negative eggs. So, here we have then an equation. Let me write the equation then for this situation. So, let's say number of eggs is equal to 2 times the number of chickens. So if I have 1 chicken, I put 1 in here, I multiply it by 2, and I get 2 eggs. Okay, this is the equation for this situation, and I'm actually going to change it now and call it y equals 2x, because this is the x-axis and this is the y-axis. So if I put a number in here for x, like 5, I'm going to find 5 times 2 gives me 10, which is up the y-axis, that's the number of eggs I get. All right, so this describes the relationship. Now, this number right here, the 2, is called the constant of variation. And that is usually represented with a k. But you may notice something about the constant of variation. It actually is the same thing as a slope in a linear equation. Now, here's the difference. Let's put y equals kx. Let me move that over a little bit because I'm not sure how far over the camera goes. Y equals kx. All right. And I'm going to put a linear equation here, y equals mx plus b. All right. This k matches up with the m. So the k, well, it's called the constant of variation, is also the slope. And the b value over here is a 0 because this is plus 0. We do not have a y-intercept other than 0 in a direct variation equation. Okay, your job is often with these, I'm going to move this up. Your job with direct variation equations is often going to be to find the constant of variation and then to write the equation. So let's suppose y varies directly with x. That means y equals kx. What we're saying is y is going to vary depending on what we put in for x. Now, we have a general equation here, like the y equals mx plus b equation for a linear equation. However, we would like something more specific now. So let's say we have a situation in which when x is 8, y is 72. Now, what we want to find is the equation that represents this situation. So, we're going to put the x and the y numbers in. So 72 equals k times 8. And I want to solve for k. I want to know what the constant of variation is for this situation. So I'm going to divide by 8, and I get k equals 9. All right? Now I have an equation, y equals 9x. Now if I put an 8 in, I get a 72 out. 8 times 9 is 72. But now I've set it up in such a way that I can put any number I want in for x. I can put a 1 in and find that y is 9. I can put a 2 in and find that y is 18. Okay, and that was our goal in this case, was to establish the equation. Now you might be asked to go a step further and then say, well, what is y if x is 10? So you put the 10 in here, and you get 10 times 9. So if x is 10, y then would be 90. All right, some of these are going to be word problems, but this is the concept of how they work. And let me see if I can help you with another sort of problem. Suppose y varies directly with x. Write a direct variation equation that relates x and y. All right, and then solve it for a particular number. So let's take one of these here. If y is 15, let's say y is 15 when x is 3/4. All right, so you leave that up. So we have y equals kx. Now y is 15 when x is 3/4. All right, what we want to do is find the constant of variation. So I'm going to multiply both sides by 4/3. These two cancel, and I get k by itself. And over here, 3 goes into 15 5 times, and 5 times 4 is 20. So k is 20. So the equation then is y equals 20x. Okay? Now the rest of the problem says, find x when y is 25. Hold on a second. Yes. Find x when y is 25. All right, that's a little different from what I was expecting, because oftentimes they will say find y when x is a certain number. Find x when y is 25. So I put 25 in for y, and I get 25 equals 20x. Divide by 20, and I get 5/4. So x equals 5/4 when y equals 25. So be sure and read the question carefully, because it may say find y when x is a certain number, or it may say find x when y is a certain number. And it's important to read that to see where you plug in the numbers and what you're solving for. All right, that's an introduction to direct variation. And that was section 3.4 in your book. And this concludes this lesson.